Good morning everyone. So welcome to the third video on the homework portal. Let me share my screen. Yeah. Okay. So I not put it in the full screen mode because it was not visible. The pen was not writing some one or the other problems I faced. Hence I put it only in this mode. Anyway, let us begin. Okay, so yesterday I had put across some questions and today we are finding out the solutions for this. The first question reads that, okay, fine. Anyway, I have put some animations, but unfortunately, since it is not in full screen mode, you will not be able to view. Okay, it doesn't matter. But now what I need is, oh, just give me a moment. Let me try with this. I'm not sure whether it works or not. Okay, now I think it works. So the graph shows the variation of the speed v. Oh my God, it's not been shared. Just give me a moment. Right. So the graph shows the variation of speed v with object with time t. Okay, v versus t is given, which graph shows the distance s traveled by the object with respect to time t. So vt graph is given to you. You need to find out the corresponding st graph. Now, how do we do it? Now, as you observe here, let me draw a slope here. Same problem once again. Okay, let me draw a slope here. If I draw a slope here, okay, I'll just show it across here. And I don't know what is wrong with this. See, it's showing an eraser. Okay, I have drawn a slope over here. The slope is seen to be a constant. When the slope is constant, what do you understand by it? You can know that the acceleration is a constant. Because it's a VT graph, acceleration should be a constant. Thus, in this region, where is it? In this region, the acceleration seems to be a constant in this region. Now, if you look at the topmost region, okay, now, if acceleration is a constant, which means what does it tell you? It tells you can use your equations of motion. If you can use equations of motion, then what is the relationship connecting displacement and time taken? Relationship is S equal to ut plus half at square, right? S equal to ut plus half at square, which I have put it over here. Okay, and thus, now in that case, this S versus t will not be a straight line. Definitely, this is incorrect. This is incorrect. Then it cannot be something like this also, because you see here it is linear, here it is also linear. So this and this shape will not be mimicking the same thing. This can be true only when S is proportional to V. See, S is not proportional to V here, right? So therefore, this is also incorrect. This is also incorrect. This is also incorrect. Then, now let us look at this. Now here you see it increases slowly and then there's a linear relationship, and again it goes up over here and finally it remains a constant. Now let us look at this region over here. Here acceleration is positive. Agreed, acceleration is positive. When it comes down this curve over here, now you see in this region acceleration is negative. When the acceleration is negative, what does it tell you? It tells you that the slope should be negative, right? Slope should be negative over here. But what is it we need? Is this a constant acceleration? Yes, this is a constant acceleration. Okay. So therefore, now once again, you should get some linear kind of plot over here. There should be a saturation. Then, now here, if you observe the plateau region over here, a tangent drawn to this will give you a slope equal to 0. Now, if you get a slope equal to 0, which means what? The velocity is constant. If the velocity is constant, in the distance and velocity relationship, how should the curve look like? Okay, if the velocity is constant, no acceleration, then which equation are you going to use? You are going to use S is equal to V into T, right? S equal to V into T. So which means as time proceeds, And for a given time, S is equal to V or S is proportional to V. That's what you come to know. Now you look at this region, this flat region here, and you look at this region. Are they coinciding? They're definitely not coinciding. Okay, one is going in this direction, the other one is going upward direction. Right? So definitely this is not the correct one. This is not the correct one. Now, which is the correct one then? This is the correct one. Now let us verify whether it's correct or not. See, here the acceleration is a constant. Acceleration is a constant. You get a parabolic curve like this. Then you see acceleration becomes zero, or velocity is almost a constant. In this region you observe. Okay, so you get almost a straight line over here. Why do you get a straight line? Because S is proportional to V over here, right? So here V is a constant line, it's a straight line parallel to the time axis. In a similar way, here also, that's what you get here. And then later on, the velocity keeps on decreasing over here. What is the speed keeps on decreasing over here? When speed keeps on decreasing, but still the acceleration is also reducing over here. Now you see the distance is still increasing, right? Because it's distance can never become negative. So therefore, D is the right option. Okay. Now let me move on to the next one. What is the change in the speed of the graph shown by the object? Now here what you need to do is you need to look at, okay, this is a plot of A versus T. Now if it is A versus T, now what is it you will get over here? See, the area under the curve will give me the change in velocity, right? The area under the graph gives me the difference in velocity. That's what you get over here. And as a result of it, you get V2 minus V1 over here. What is being asked? Change in speed of the object shown by the graph, right? So what you need to do? You need to find out the area under the curve. Now you see, that's what I have done. Change in velocity should be equal to, this is nothing but your triangle, half into B. What is B? 6 multiplied by height, 12, right? Half into 12 into 6, which will give you 36 meters per second. So the correct answer here is nothing but C. Okay, the answer here is C. Right, let me move on to the next one. An elevator and its load has a total mass of 750 kgs and accelerate vertically downwards at 2 meters per second square. Now you have a lift, the lift is going downwards, and this is a cord of the lift. Okay, the cable of the lift. There's a load kept over here. What is the tension in the elevator cable? Okay, what is the tension acting here? How do you do? First thing is you need to draw a free body diagram. How do you draw the free body diagram? So towards it, first find what is the direction of motion of the object. What is the direction? Like this. So if that is the case, let me write this as A here. And then, which is the first force acting downwards? mg. So you'll write mg. What is the opposite force? Opposite force is T, right? If this is positive, then this should be negative. So thus, this is system. Okay, I've written it here. So thus mg minus T is equal to ma. Why ma? Because it's a net force, right? When Newton's second law of motion, we know that the net force is equal to mass times acceleration. So mg is taken as positive, then T is taken as negative over here. Though conventionally we take T to be positive, but here I take this to be positive and the other one to be negative. Why is it? What is the reason? The reason is because now you see, so mg is nothing but the direction of the force which is acting on it, and the object moves in the same direction. So I have taken this as positive. Otherwise, if the object was moving upwards, then what should be the force direction? It should be T minus mg. T will be taken as positive. Okay. T should be equal to m into g minus a. Substitute the values. You get the answer 6,000 newtons. Thus, the correct answer here is seen to be 6 kilonewton. I hope you understood this particular problem. Okay, you should know clearly how to draw the free body diagrams. Next, a horizontal spring of spring constant K and negligible mass is compressed to a distance y. So what did you do? You took this object, you compressed it. An object of mass m that moves in a frictionless surface is placed at the end of the spring. The spring is released and returns to the equilibrium position. So it goes back to the equilibrium position. What is the speed of the object just after it leaves the spring? So what should you do? Why did the object get compressed? Why did the spring get compressed? Because you applied a force, right? When you applied a force, the spring got compressed. Now, why does the object come back like this? Because the spring, what does the spring do? Releases its energy, right? It goes from a compressed position to a relaxed position. So therefore, now as it moves, now initially here you see the velocity of the object will be much lower. But when it keeps on moving like this, when it reaches this point, velocity would be very, very high. Now what is being asked? What is the speed of the object? Okay, which means the moment it crosses this region, immediately the spring does not go hand in hand. Only the object moves while the spring stands there itself. So therefore, why should the object move? Who gave the energy to move? The spring energy was given to the object. Right? There was some potential energy stored in the spring. What is that potential energy? elastic potential energy. This was stored in the spring. This spring energy was given to the object, and hence the object started moving. So towards it, now what we do is, we'll write down the equation. Oh my God, I have not written the equation. Okay. So I will write down the equation. My pen is not writing. It should be half ky square is equal to half mv square, right? Because this is completely frictionless. So towards it, what is that we need? We need the value of v. So this half and this half goes away. V should now be equal to square root of k divided by m into y. What is the right answer? K by m into y. The answer is E. Okay. So like this, you should know how to apply which formula, right? Okay. Now, some of you would have made a mistake in this case. I think I have discussed this in one of your misconceptions in physics also, one of the videos, wherein what you do is, instead of applying this one, you will do something like F is equal to F is equal to minus Kx. And then you differentiate it, do all these things. So you won't get a correct answer. Okay. It is better that you go by this method. Right. Now let us move on to the next one. A car traveling at a constant velocity covers a distance of 100 meters in 5 seconds. What is given? Distance is given. Distance is given. Wait. Right. Now distance is given here. My pen doesn't write. Okay, distance is given, time is given, and then the force is given. Now you need to find out the power. Now how do you find the power? Power. Wait just a moment. Let me take it up. Okay. Just give me a moment. Let me just. Okay. Let me just tell you the method. Power is equal to force multiplied by distance divided by time taken, as you are all aware, right? So therefore, now what I will do is, I will write power is equal to force into distance divided by time. Why did I write like this? Because it's nothing but work done divided by time taken, right? What is force? Force is nothing but 1.5 kilonewton multiplied by distance. What is distance? 100 meters. 100 meters divided by time, 5 seconds. 100 meters divided by 5 seconds. So how much will this be? This will be, how much will this be? 5 ones are 5, 0.3s are, and this should be 300 kilo. Now unit, what unit? What is the unit over here? Newton meter per second. How much will this be? 300 watts. Okay, 300 kilowatts. 300 kilowatts. Do I have this answer? No. Why? Let us add here. 300. (1.5 kilonewton, 0.3, 0. Oh my God, I made a mistake here. 0.3 multiplied by 100 is 30, right? Array, mathematics में थोड़ा कमजोर हूँ यार. Okay, 330 kilonewton. 30 kilonewton. Kilowatts, sorry. Kilo, array. See, we have been going to the same conventional way. Kilowatts. That's it. Okay. With this, we come to an end to today's solutions. Let us meet once again tomorrow. Thank you. If you really like this video, do share and subscribe to my channel for more updates. Thank you.